In this video, we are going to learn how to solve this WASSCE or chemistry problems under empirical and molecular formula. So guys, we have 7 repeated questions to practice with in this video. Let's get started. The first question I have here says the empirical formula of a compound containing these values is okay. So let's solve this, guys. This is actually easy. Let me show you how you can solve empirical formula. So firstly, let's get the elements we have there. We have our copper. Okay, let me write it here. We have copper, we have oxygen. So we already have the mole values. So we have the mole value of copper to be 0.067. we have that of oxygen to be 0.066. so divide through by the least mole ratio. The least value here is 0.066. Okay, so let's make a calculator and punch this. Though this one will give you 1. Okay, but let's verify this. Okay, let's just verify with the calculator. So this will be 0.067 divided by 0.066 press equal to, so we have it to process this in decimal, so we have it to be is still 1. Okay, so at this juncture this will still give you 1. So this shows us that the empirical formula rather will be, since the mole ratio is 1:1, so the molecular formula will be copper oxide. So the right option is option what? C. Okay, so that's it for this question. Let's wipe this now, solve the next repeated question. So the next repeated question will be this one. It says, what is the empirical formula of a hydrocarbon containing 0.08 moles of carbon and 0.32 moles of hydrogen? So guys, it's still the same procedure. So let's write down the elements. So we have the first element here, we have carbon, we have hydrogen. So the mole value for the carbon, we have it to be 0.08. that of hydrogen is 0.32. divide through by the least mole value to get the mole ratio. So it will be the least value here 0.08. Alright, this will give you 1. So let's punch this in a calculator to get the other value. So we're going to have 0.32 divide 0.08. what's the output? We have it to be what? 4. Alright, so this gives us 4. If this divided, they are going to have 4. So this shows us that the empirical formula will be CH4. So this is what? Methane. Okay, option B. So that's it for this question. Let's wipe this now, solve the next repeated question. So the next repeated question will be this one. So the question says, what's the percentage composition of carbon in this compound? Alright, so before you solve this, first let's get the molar mass of the compound. So the molar mass of this compound will be, so for calcium, yeah, the electric atomic mass is 40, and we're having 1 atom of calcium there, so it will be 40 plus. Then for hydrogen, the number of atoms is 2, because this value outside here is affecting every other element inside the bracket. So the relative atomic mass of hydrogen is 1. That's 1 times 2 plus carbon is, we have 2 atoms of carbon. These 2 are fetching the carbon inside, and the relative atomic mass of carbon here is 12. That's plus 12 times 2 plus, for oxygen we have total number of atoms for oxygen here to be 6. 3 times 2 outside, that's 6. So, and the relative atomic mass of oxygen is 16. That's plus 16 times 6. Alright, so let's break this down. So this is going to give us, we have 40 plus 2 plus 24. Okay, so this will give us 16 times 6. So 6 times 6 is 36 plus, so this is going to give us plus 96. So let's add this together. This will give us, when you add 96 plus 24, you're going to have 120. So 120 plus 40, 160. 160 plus 2, you're going to have 162. So this will give us 162 gram per mole. So that of carbon, molar mass of carbon alone here is 24. So the percent composition of carbon will now be 24 over 162 times 100 over 1. So let's point this on the calculator now. So this will give us, we have in fraction 24 over 162. Okay, then we have times 100. That's all. Press equal to, press SD. So we have it to be what? Press SD again. 14.81. Alright, 14.8%. That's the percent composition of carbon. So the right option is option B. It's as simple as this. Let's wipe this now. Solve the next repeated question. So the next repeated question will be this one. It says, what is the relative molecular mass of a compound which has empirical formula of this? So let me show you. This question is actually very simple. Let me give you the idea of how to solve this. So firstly, what's the molar mass of this empirical formula? We have how many atoms of carbon? We have it in 1. So that's, this atomic mass of carbon is 12. So this will give us 12 plus hydrogen, 2 atoms of hydrogen. Relative atomic mass of hydrogen is 1. That's plus 2 times 1 plus oxygen. We have 1 atom. That's plus 16. When you add this, you're going to have 30. Okay, so now that we have this 30, this shows us that the relative molecular mass of a compound which has this empirical formula will be the value that 30 is a multiple. So 180 is a multiple of 30. So this shows us that the right answer here is option C, since 180 is a multiple of 30. When you times 30 by 6, you're going to have 180. Okay, so 180 is the answer to this question. So it's as simple as this, guys. Let's wipe this now and solve the next repeated question. Okay, so the next repeated question will be this one. It says, what is the percentage composition of oxygen in, this is potassium chromate 6. Okay, so let's solve this. Now we are looking for, just like the way we solve the that question, now we're going to solve this. All right, the molar mass of this compound will be, so we have potassium to, well, we have 2 atoms of, okay, we already have it, they gave it to us here, 294. So all we need now is to get the molar mass of oxygen. We have 7 atoms of oxygen here, so this shows us that it will be 16 times 7. Okay, so when you simplify this, you're going to have 112. Right now, to get the percentage composition of oxygen in this compound, is going to be 112 over the total molecular mass there. That's 294 times 100 over 1. So let's point to the calculator. So we're going to have in fraction 112 over 294. Okay, times 100. That's all. Press equal to, we have the output to press SD. Press SD again to 38.09. So the right option is option C. That's it for this question. Let's wipe this now, solve the next subject question. So the next subject question will be this one. It says an organic compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. What is the empirical formula of the compound? Okay, so let's solve this, guys. Let's do it together. So firstly, we have the elements to be, we have carbon, we have hydrogen, and we have oxygen. Now the percent composition, we have the carbon to be 40, then this one is 6.7, and this is point, guys, and this one is 53.3. all right, so let's put in percentage. So the relative atomic mass of carbon, we have it to be 12, hydrogen we have it to be 1, and oxygen we have it to be 16. Now to get the mole ratio, divide the percent composition by the relative atomic mass. Okay, so that's the procedure. So let's bring a calculator and punch this respectively. So firstly, we have 40 divide 12. We have the output to be what? Press SD 3.3. okay, this one is to give us 6.7. then what of 53.3 divide 16? So we still have 3.33. okay, so guys, let's just leave it in two decimal places. So this gave us 3.33, this is 6.7, let's add 0, this is 3.33. so at this juncture, divide through by the least mole ratio, which is 3.33. okay, 3.33. so this will give you 1, this will give you 1. So let's check the value for the other one. That's 6.70 divide 3.33. the output is what? Okay, we have it to be 2.01, so it's still 2. okay, so the mole ratio is 1 is to 2 is to 1. So this shows us that the empirical formula will be CH2O. okay, so that's the answer to this question. The right option is, let's take option B, CH2O. So that's for this question. Let's wipe this now and look at the last question. So the last question will be this one. It says, which of the following is the relative molecular mass of a compound which has a empirical formula of this? I think I saw this question already. We got it to be 180, which is a multiple of 30. So guys, this basically can do a problem involving empirical formula and molecular formula for a WASSCE chemistry practice with several the question for this video. Hope there's something interesting from this video. Let's go to the video, guys. If you are new to this channel, ensure that you are subscribed to this channel by hitting the subscribe button for more of these videos. Also like, share, and comment on this video. Let me know how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I talked about in this video, feel free to leave your question at the comment section below, and I'll be sure to give you a response. Also ensure that you're part of the channel membership by clicking the join button. We are getting premium information will help you to excel in your external exams like WASSCE and other external exams you'll be writing. Alright, so having done this, click on the screen above and I'll see you in the next video. Thanks for watching.